Welcome to the Gas Law Masterclass, where we will learn the 5 basic gas laws that you will need to know in any chemistry class. The 5 topics that we will be learning today are the basic gas law, Charles's law, Boyle's law, Gay-Lussac's law, and the combined gas law. The first law that we will be learning today is the basic gas law. So the basic gas law is simply PV equals nRT, where P stands for pressure, V equals volume, N equals the amount of substance, R equals the ideal gas constant, which is 0.0821 liters times ATM over Kelvin times mole, and T equals temperature. The next gas law that we'll be going over is the Charles law, which is V1 over T1 equals V2 over T2. The question that we will be solving is a 275 milliliter balloon is filled with air at 25 degrees Celsius. If the temperature is raised to 50 degrees Celsius, what is the new volume of the balloon? So what we will try to find is the V2 in the equation. So now that we have all the numbers in place, we now need to plug them into V1, T1, V2, and T2. So for V1, we have 275 milliliters, T1, we have 298 Kelvin, V2, we're not sure yet, and T2, we have 323 Kelvin. So you might be wondering, how did I get to that number of Kelvin? So what I did is I took the 25 degrees Celsius and added it by 273, and that's how I got to my 298 Kelvin. And I did the same process for the 50 degrees Celsius to get 323 Kelvin. Okay, so now that we have all of our numbers in place, we can now plug them into the equation. First, we have 275, or V1, divided by 298, or T2, and that is equal to V2 over 323, or T2. So now what we can do is cross multiply by doing 323 times 275, which is equal to 88,825, and now we can do 298 times V2, which is 298 times V2. So now we can divide 298 by both sides and leaving V2 on its own. Now we have 88,825 divided by 298, which is 298. So our final answer for this question is V2 equals 298 milliliters. The next gas law that we'll be going over is Boyle's law, which is P1 times V1 equals P2 times V2. The problem that we'll be trying to solve is a 2.5 liter gas container has a gas pressure of 4.6 atm. If the volume is decreased to 1.6 liters, what will the new pressure inside the container be? Now that we have all the numbers in place, we can now plug them into the equation. So for P1, we have 4.6 atm, V1, we have 2.5 liters, P2, we're not sure yet, and V2, we have 1.6 liters. Now it's time to plug the numbers into the equation. So first we have 4.6 as P1 times 2.5 V1 equals P2 times 1.6, which is V2. Now we can do 11.5, which is 4.6 times 2.5 equals 1.6. Now we can divide 1.6 by both sides, leaving P2 by itself. To finish up the problem, we can do 11.5 divided by 1.6, giving us 7.2. So our final answer is P2 equals 7.2 atm. The next gas law that we'll be going over is Gay-Lussac's law, which is P1 divided by T1 equals P2 divided by T2. The problem that we'll be solving is the pressure in a sealed can of gas is 235 kilopascals when it sits at room temperature, 20 degrees Celsius. If the can is warmed to 48 degrees Celsius, what will the new pressure inside the can be? Now that the problem has given us all the numbers we need, we can now plug them into the equation. So first we have P1, which is 235 kilopascals, T1, which is 293 Kelvin, P2, we're not sure yet, and T2 equals 321 Kelvin. Now that we have all the numbers in place, we can plug them into the equation. First, we have 235 divided by 293 is equal to P2 over 321. We can then cross multiply and get 75,435 equal to 293 times P2. Now we can divide 293 on both sides, leaving P2 by itself. Now we have 75,435 divided by 293, giving us 257. So our final answer will be P2 equals 257 kilopascals. The final gas law that we will be going over is the combined gas law, which is P1 times V1 over T1 is equal to P2 times V2 over T2. The problem that we will be attempting to solve is a gas balloon has a volume of 106.0 liters when the temperature is 45 degrees Celsius and the pressure is 0.974 atm. What will its volume be at 20 degrees Celsius and 1.03 atm? Now that the problem has given us all the numbers we need, we can plug them into the equation. So for P1, we have 0.974 atm, V1, we have 106.0 liters, T1, we have 318 Kelvin, P2, we have 1.03 atm, V2, we're not sure yet, and T2, we have 293 Kelvin. Now that we have all the numbers laid out nicely for us, we can plug them all into the equation. First, we have 0.974 times 106 divided by 318 is equal to 1.03 times V2 divided by 293. First, we have to solve the equation on the left-hand side and get 0.32, and that will be equal to 1.03 times V2 divided by 293. Next, we have to multiply 293 on both sides to get 93.76 equal to 1.03 times V2. Next, we have to leave V2 by itself by dividing 1.03 on both sides, getting us 93.76 divided by 1.03, and there we will get 91. So our final answer will be V2 is equal to 91.0 liters.